Hello everyone, welcome back to our second assembly programming video. In this video, we're going to practice a few more assembly commands, including a couple extra moves and an add, and just get a little more comfortable with the process. So if I look in my videos folder, we have prog 1 completed, and now we're going to work on prog 2. So again, I encourage using the nano editor, and so we're going to go to nano prog2.s. Remember, assembly programs are .s. And so we'll end up with a blank file to start with. Oops. So let's create a little block for our comments here. This is called prog2.s. In this program, we will add 50 and 60 and return the result. And the author of this program is myself, Ryan Macfeld. Cool. So as we did with program 1, we're going to start the same way. .syntax unified .global underscore start, and then we'll start with our underscore start label. All right. So this will be a really standard way to open all of our assembly programs. And if you really want to get at, well, we'll worry about the rest of this later. So, okay, so we're ready to start. I'm not going to jump too far ahead of myself. Let's move in and start by moving into register 1 the value 50. Now in our last program, I started with register 0. I'm starting with register 1 this time because 50 is not the value we want to return. R0 is our return register, and we don't want to return the value 50, so I'm not going to move it into R0. Now later I could have overwritten R0 or changed it, but it's just a generally good convention to avoid R0 as you do this, unless it's the value you want to return. So I'm going to leave a little comment. Remember the @ sign means an inline comment saying that we set R1 equal to 50, and then we're going to move into R2 the value 60. And finally, we're going to add R1 and R2, storing the result in R0. So you'll notice with assembly commands, the first value that you put in is typically the destination register. So here I'm going to save the result, the destination of my addition, in R0. And I'll add R1 and R2. So again, this is equivalent to saying R0 equals R1 plus R2. And R0 is our return register by convention. So we're pretty much done here. We just need to exit our program, which means we need to do this 2-line sequence when we're returning an integer, which is move into R7 the value 1, which means return integer when exiting. And SWI 0 is our system interrupt that actually ends our program. So this is our full program. We're saving the value 50 into one register, the value 60 into another, and then we are adding those two registers together, storing the result in R0, which is our return register. All right, so Control X or Escape X. Are you done saving? Y for yes and for no. So I'll hit yes. File name is prog2.s, and now prog2.s exists. So let's go ahead and go through our assembling and linking process. AS-O, prog2.o, prog2.s. So we're assembling an object file, prog2.o, from our assembly file, prog2.s. And then we are linking this to an executable from our object file. And so our executable we will call prog2. And we will create that from our object file, prog2.o. Again, if we look at our file structure now, we have prog1 and all of its the assembly for prog1, the object file for prog1, and the executable for prog1, and now we have the same thing for prog2. So we can run it with /prog2. Again, there's no printouts, so there's no result, but we can use our echo command, echo $? to print the value stored in our output register, R0, which is the value 110. So in this program, we have successfully added 50 and 60, gotten the result 110, and returned it in our program. See you guys next time.